How does the brain adapt to DBS for Parkinson's symptoms? Imagine your brain as a busy city with many roads and signals constantly flowing. In Parkinson's disease, some of these signals become overactive or out of sync, causing movement problems. Deep Brain Stimulation, or DBS, is like installing a smart traffic controller in the city. It sends tiny electrical signals to specific areas in the brain, most often the subthalamic nucleus or globus pallidus internus, to help smooth out the traffic jams. But how does the brain actually adapt to this new control system? When DBS is turned on, it works by disrupting abnormal brain activity patterns, especially excessive beta waves that are linked to the motor symptoms of Parkinson's. These high-frequency electrical signals suppress these abnormal oscillations, which helps restore more normal communication between brain regions involved in movement. For example, stimulating the subthalamic nucleus reduces the overactive signals that cause tremors and rigidity. It also influences the globus pallidus externus, helping to balance the signals that control movement. At the cellular level, DBS mainly activates the tiny fibers called axons and dendrites near the stimulation site. Instead of directly killing or silencing neurons, it increases the firing of action potentials in these fibers. This selective activation helps override the abnormal firing patterns without shutting down the normal activity that keeps your movements smooth and coordinated. Over time, the brain begins to adapt to these changes. It can modify how neurons connect and communicate, a process known as plasticity. These changes may help maintain the benefits of DBS even after long-term use. To optimize this, doctors now use adaptive DBS systems that adjust stimulation in real time based on signals from the brain, like local field potentials, which reflected symptom severity. This closed-loop approach means the stimulation is personalized and dynamic, helping to control symptoms more effectively while reducing side effects and conserving battery life. In essence, the brain adapts to DBS by disrupting the abnormal rhythms that cause symptoms, modulating neural activity in targeted areas, and gradually reorganizing its connections. This ongoing adaptation is why DBS can provide lasting relief for many people with Parkinson's. However, because each person's brain responds differently, it's important to work closely with a neurologist or movement disorder specialist. They can tailor the therapy to fit individual needs and ensure the best possible outcome. Always remember, medical treatments like DBS are complex, and ongoing research continues to improve how we understand and optimize this advanced therapy.